Hey everyone, and welcome back to this class, Recommender Systems in Python. In this lecture, we are going to outline each of the topics you'll be learning in this course. The first section of the course is devoted to non-personalized recommendation systems, and will cover some algorithms being used by the most popular websites today. Some examples are Reddit, Hacker News, and Google PageRank. The common theme of these methods is that it doesn't matter who you are. When you go to Hacker News, you see the same thing that I see when I go to Hacker News. But make no mistake, these are not just toy algorithms. Google's PageRank is the reason why Google is a billion-dollar business today, and why it's the most popular website on the internet. Reddit recently made it to 6th place in the Alexa rankings, right under Wikipedia. One common algorithm that's being used by many media companies today, such as BuzzFeed, makes use of a Bayesian paradigm of statistics. It's fast, scalable, and anyone can use it. So it's no wonder that it's been adopted so widely. The algorithms you learn about in this section are being used by the biggest companies on the internet. The second section of this course is devoted to collaborative filtering. Whereas the first section sorts each item in the same way no matter who you are, collaborative filtering takes who you are into account. So if I liked The Notebook and A Cinderella Story, then maybe Titanic is a good recommendation for me. But if I liked Paranormal Activity and The Ring, then maybe Titanic isn't such a good choice. Collaborative filtering is all about taking into account things I've liked and finding other things that are similar. But not only that, we can use users who are similar to me to recommend things to me that I haven't seen yet. Starting in this section, we're going to start putting our math and programming skills to good use. You'll get a chance to implement each of the algorithms we learn. So if you aren't being hands-on in this course, then you aren't doing it right. The next section is the real meat of this course. We are going to learn about matrix factorization and its variants, like probabilistic matrix factorization, to take recommendations to the next level. Matrix factorization is also sometimes called SVD, so if you came to this course looking for that, then you are in the right place. As you know, I'm not the type of instructor to just show you a few fancy pictures and say a few nice words and call it a day. We are going to learn about matrix factorization from scratch. We are going to derive each piece of the matrix factorization algorithm so that you understand how it works on a fundamental level. Of course, you're also going to practice implementing it, and it's going to be challenging, but it's going to be fun. Finally, we're going to look at how deep learning can be applied to recommender systems. A lot of my students have expressed interest in using Keras because it's so simple and yet such a powerful tool for deep learning. And indeed, we're going to see how easy it is to convert our matrix factorization code into a Keras script. But of course, Keras is capable of so much more. We're going to see how we can modify our script to use a deep neural network instead of just matrix factorization. But not only that, we're going to borrow ideas from computer vision, specifically residual networks and inception, to see if we can improve upon just a single neural network. And after that, we are still not done. We'll also see how unsupervised deep learning can be applied to build recommender systems, specifically autoencoders in restricted Boltzmann machines, although our focus will be on autoencoders. Finally, for those of you who haven't yet set up your development environment, or you want some tips on how to navigate this course, we have the appendix. The appendix was set up to answer some of the most common questions I get from students. I get these questions daily, so it's nice to have a comprehensive set of lectures to help students and give them in-depth answers to their questions. For example, if you need help with how to get started coding a machine learning script and what its structure should look like. Or if you want to understand the difference between this course and a typical academic course or a typical online course. Or if you want to know what path you should take to get really good at deep learning without going crazy trying to figure out all the weird math symbols, then this section is for you.